Welcome to the University of Michigan Dentistry Podcast Series, promoting oral health care worldwide.
The topic today deals with the modification of radiographs. There are times when a given set of radiographs that you've made of a patient aren't examples of your very best work. They may be too dark or they may be too light. You would like the opportunity to redo the job, but it's not possible. The patient has gone. He has written to you asking that you send the radiographs to his new dentist who's located in another state. He now has another job, and it's a perfectly legitimate request when he asks that you send the radiographs to his new dentist. You sort of hate to do it because they're really not too good. Now, they may be too dark because you've overexposed them, or perhaps overdeveloped, or they may be too light again due to underexposure or underdevelopment for whatever the reason. So we would like to modify these radiographs and make them appear more normal. Now, to do this, we must first understand the composition of our dental films. Now, a dental film has a plastic sheet as its basis, and this is called the film base. It has a slight blue cast to it. Some people think the blue is pleasing to the eyes. And then on either side of the film base, there is an emulsion layer. This is made largely of gelatin, and interspersed in the gelatin are grains of silver. Now, when the film has been processed, these become black metallic silver grain. We place the film in front of a light source, such as a view box, and light of high intensity strikes the near side of the film, and then that light ray tries to get on through the film. But many obstacles in the presence of silver grains occurred, and so not too much of the light got through to the observer's eye. And so we would say that in this example, there were too many obstacles to the passage of the light, too many silver grains, and so the mind of the observer would judge that this film was too dark. Now, an example of such a dark film is shown here. This one is too dark, this one is normal, and this one is too light. Now we'd like to go to the treatment called reduction. This is where we will take a dark film and lighten it. Now, reduction is a chemical treatment which is applied to dark films, whether it's due to overexposure or overdevelopment, and it's done to reduce their density and their contrast. Now, the entire process takes place in the lighted room. We don't have to go and hide in the dark room. Now, this reduction treatment can be applied to films that have been dried for an indefinite length of time, or can be applied immediately to films that have just been processed and are still wet. It matters not. The chemicals that are used are relatively simple chemicals obtainable at a photographic shop. They're inexpensive and readily available. Now, turning to this chart, we have too many obstacles in the path of the light reaching the observer's eye. Now, if I were very clever with a razor, perhaps I could just slice the film and remove the layer that contains these grains nearest the surface. But I'm not that clever. So what we'll do instead is to remove these grains chemically. Now, the way we'll do that is to immerse the film in a bath. Now, the whole film is immersed in this bath. The action is going to penetrate in from these two surfaces. What happens through the edge of the film is insignificant. As soon as the first bath penetrates the film enough, it is going to cause these surface grains here to change chemically. So I'll just color them in slightly so that we can differentiate them from the others. Now the same thing, of course, would be happening to the grains over on this side. Then after I have modified those surface grains so they are different than these that are deeper, then I will remove these grains that I've modified so that all will be left will be the unmodified grains. Now the silver, or the image on the radiograph, is composed of minute particles of black metallic silver. So that's what these grains represent, and these that I've colored represent the modified ones, which we will remove. Now I have a beaker here, and I have two solutions, solution A and solution B. Now, solution A is made up of water and potassium ferricyanide. Solution B is made up of water and a thiosulfate. It can be either ammonium thiosulfate or sodium thiosulfate. The sodium thiosulfate is commonly called hypo in photographic terminology. So I'll pour out a small quantity of solution A into the beaker. And then solution B, an equal amount. Solution B is colorless. Solution A is yellow. Now the solution would perhaps act too fast, and so I'll have to add some water to dilute it. There's our working solution. Next, we'll take one of these dark films. Well, let's not touch this one that's too light. We'll not touch the normal one. We'll not treat the too dark one, but we'll treat all the others. So I'll take this one, and we'll modify it chemically using this two-solution reducer. Now, this film has been dried for a long time, and so I'm going to put it in water here just to start the gelatin swelling a bit. Now we'll put the film in this bath. Now what is happening is what I illustrated on the chart. The silver grains that are lying near the surface are being transformed into silver ferrocyanide. But then just as soon as they are altered, changed into silver ferrocyanide by solution A, solution B dissolves them off. It has a selective action. It dissolves silver ferrocyanide but does not dissolve silver grains. Now I want to check and see whether I have modified the film sufficiently. So we'll rinse it just to get rid of the surface solution and then hold it up. Well, it's not quite as light as I should like it. So we'll return the film to the bath for further treatment. Agitation sort of speeds up the process. Now, if this film had greasy fingerprints on it, the presence of the grease would prevent the chemicals from acting. So films must be cleaned if they have these greasy fingerprints. Any organic solvent is useful for that purpose. So again, we take another peek, and this time I think perhaps the film has become lightened enough. Next, the film should be washed in running water for 20 minutes. Now, we're not going to take the time to do that. I'm just giving it a cursory rinse in this water. Now I should like to dry the film rapidly so I can put it back in the mount. In this beaker I have some absolute alcohol. Now that's a very thirsty chemical, and so it's drinking up all of the moisture from the film. The alcohol itself evaporates quite readily. So now I'll put the film back in the mount, and it will dry quite soon. Now, while that's drying, let's take the next dark film and we'll treat it by another method. The method I've demonstrated so far has involved treatment of both sides of the film. The treatments that we will go to now will involve treating only one side of the film. I have a bottle of nail lacquer, the kind that the gals like to use, and I'm going to paint one side of my film. Now, all I'm really doing is putting a waterproof coating on this surface of the film. Now, instead of using nail polish to do this, I could use varnish, I could use Vaseline, but Vaseline is a bit messy. It gets on your fingers readily, and it would get transferred to the other side of the film. Now, I'm not very good at this painting job. We should have a gal doing this for us. Now it's going to take just a few minutes for this material to dry, so I'll set it safely aside. And while that is drying, we'll prepare another one of these several dark films. Now this dark film I will place on a sheet of wax. Now what I want to do is to burnish this film into the wax. So I place a sheet of paper over top of it, and then with my thumbnail, exerting lots of pressure, I'm burnishing the edges of this film packet down into the wax. So the lower surface of the film is in contact with the wax, and only the upper surface of the film is available to me for this chemical treatment. Now we'll remove the paper, and there is the film in its secured to the wax. Now we'll put that in a tray. I see my burnishing job wasn't quite successful. Let me work a little further on this corner. See, I can't allow the solution to reach the underneath side of the film. Now we'll take some of this reducing solution and we'll pour it down this stick So it comes to rest on this radiograph. Now I'll just move the solution around so it covers all the way out to the edges. So now the solution is touching just the upper surface of the film, and the lower surface is not being treated at all. Now the length of time that it takes for this to completely remove the image from this one side of the film will vary depending upon the strength of the solution that we're using and things like that. But I would imagine a period of maybe 4 minutes would be adequate time for this to completely act. So while that is acting, we'll turn to the remaining dark film. And we want to put a protective coating on this. So to do this, I will take masking tape. Now I wish the masking tape were wide enough so that one pass would completely cover my film. But since it's not wide enough, I have to do it in 2 passes. Now all I'm doing here is trying to waterproof the one side of the film. All right, there the film is stuck to the tape. Now we'll take a scissors and chop off a little bit of the excess. Now this film we will put in the beaker, and only one side of the film is in contact with the solution. Now again, that will take perhaps 4 minutes for the chemical to eat off the picture that's on one side of the film. Now we can return to the film that was secured to the wax, and I'll simply just pour off the excess solution. A little water to rinse off the remaining yellow reducer solution. Now I'll peel the film loose from its wax cover, fasten it to a clip, give it a brief rinse. This is 20 minutes in running water that we're giving now. And this is what we have come down to. So you see the picture is less contrasty and less dense. Now to quickly dry it, we'll put it in the absolute alcohol bath. That ought to be just about enough. Now I'll put it back in the mount. And it would dry rapidly. The first film that I returned to the mount has long since been dried. Now there is one thing to be said for these techniques that treat only one side of the film, and that is the element of time. If I leave the film with the one side protected and the other side in contact with the bath for, 10 minutes, that's fine. 50 minutes, that's just as good. In other words, it is not time dependent after the image has been completely cleared from one side of the film. Not so with the 2 solution dip and peak look. That's where I treated both sides. If I were called away from my activity by a phone call and I came back 5 minutes later, I'd have no image on the film at all, just a clear sheet of plastic. That could not happen with this other method. Now let's look and see what we have with this technique where we use the tape. The film has been in contact with the solution for quite a while. I'll rinse off the excess solution. Again, 20 minutes in running water would be indicated. Then I'll peel off the tape. Now, Scotch tape does not work for this purpose. Masking tape is the one of choice. Now we'll wash the film. So we'll fasten a clip to it, put a handle on it, and then a 20-minute rinse in running water. Then we'd hang it up to dry normally, but today we'll use the absolute alcohol to dry it in a big hurry for us. Perhaps 20 or 30 seconds immersion in the alcohol is sufficient to leach out all the water. Next, we'll put the film back in its proper spot in the mount. My two previously treated films have both dried completely. Now the remaining film was the one on which we put the nail polish. Now the side that you're looking at now has the glossy polish on it. So I'll put that in the bath and then agitate. Again, the precautions of greasy fingerprints applies, because the grease would act as a barrier just as the nail polish is acting as a barrier. Now these two bottles, solution B and solution A, as long as they're kept in their individual bottles, they will last indefinitely. Once they're mixed together, they will deteriorate, and I would estimate within a half an hour of exposure to the oxygen of the air, the yellow coloring of the diluted bath would change to a bluish-green color, and the solution would have lost its potency. Now, if I have not done my painting job correctly and left little gaps on this surface, I'm going to have little clear areas on this radiograph. Now, if you want to hurry this process, we would simply use equal parts of solution A and B with no water at all. Then things happen quite rapidly. The water is necessary when you use the dip and peak look. All right, this has gone to completion. So a brief rinse. It looks quite satisfactory. Now we give a more prolonged wash, 20 minutes in running water, followed by normal drying. We'll dry it in a hurry using the absolute ethyl alcohol. Now, if you do not have absolute alcohol, and that is kind of hard to come by, you can use isopropyl alcohol, which is ordinary rubbing alcohol. This you can buy at the drugstore. Now, if you tried this same rapid drying trick with isopropyl alcohol, you would find that when the film dried, it would have a white coating on it. Now you can get away from this white coating if you will dilute the isopropyl alcohol. Use 6 parts of alcohol and 2 parts of water. Now it doesn't dry quite as fast as the absolute ethyl alcohol, but it will dry the film fairly rapid, and it will not leave a white coating. So now I'll put the film back in the mount. So we have started with 4 films that were all of this darkness, the too dark example, and we have lightened it using 4 different methods. So the results now more closely resemble the normal radiograph. For radiographs that are too large to be coated by any of the previously demonstrated methods, we have this alternate method. We simply take the large radiograph and tape its edges securely to the bottom of a tray. Thus, we have rendered the underside of the film waterproof. Then we'd simply pour the reducing solution over the film and agitate and allow it to act for a sufficient length of time to completely remove the image that's on the top surface of the film. Following that, we would wash the film and dry it. All right, this completes the various methods for the chemical reduction of radiographs that are too dark from any cause. Intensification is a chemical treatment which is applied to underexposed or underdeveloped radiographs in order to increase their density and contrast. This entire process can take place with the white lights turned on. On this diagram, we see the 2 emulsions of the radiographic film, and I've drawn in only a couple of the silver grains. This represents a film that is too light. The light that is incident upon the film travels through it and reaches very few obstacles, and so the intensity of the light reaching the observer's eye is quite great. And so the observer's mind would say this film is rather light. Now I wish I could introduce some more obstacles to the passage of the light. Now if I were to introduce them just haphazardly, I would destroy the informational content of the film. So I have to use a method which will put the extra silver grains or obstacles within the film and still maintain the information of the radiograph. Now the way I'm going to do that is to use certain chemicals. Now we start out with an intensifier stock solution. It contains potassium bichromate, K2Cr2O7, which is an orange chemical, and then a little bit of potassium bromide, hydrochloric acid, and then some water. So that makes up our intensifier stock solution. Now, I'm going to immerse the film in the intensifier stock solution, which is orange because it contains the bichromate, and it's going to penetrate and change these silver particles into another compound called silver bichromate. And then the radiograph will appear orange rather than black and white. So to accomplish this step, we'll first take some of the intensifier stock solution and pour it into the beaker. Now just a little bit of this stuff goes a long way. We'll dilute it with about 10 parts of water. It's best not to get this material on your fingers, for it will produce a yellow stain on the fingers. Now we add some water to dilute this. So roughly 10-to-1 would be the proportion that we would use. Now it's an orange-colored solution. Now we turn to our two light radiographs, and the one we will not modify, but the other one we will treat with this chemical treatment. So we'll fasten it to a clip, and this ordinary black and white radiograph will now be changed into an orange radiograph. After sufficient time, the film becomes entirely orange. We've reached that point now. I'll just rinse off a little of the solution, and the film has all been changed from the black metallic silver to the yellowish orange silver bichromate. So the next step is to wash the film. Now this will remove the excess of the yellow coloring. A couple minutes in running water is really necessary to do this properly. The film has washed for a couple minutes now. That ought to be adequate. But it still isn't a black and white radiograph. It's an off yellow color. That's because the original silver image is tied up now with chromium and also some oxygen. And as long as we have this combination of chromates, the chromium and oxygen, our picture is going to be this yellowish color. So I need a strong reducing agent to break this chemical bond and get rid of the oxygen. Now such a reducing agent is found in all dental offices, and it's called developer. So this beaker contains just ordinary developer. So we'll take the radiograph from the wash water and introduce it into the developer. Now here before our eyes in the lighted room, we see the film developing. Now we don't have to take the temperature of the developer and set a time clock or anything like that. This is done solely by inspection. As soon as all of the yellowish tint has disappeared, then the process is completed, and further immersion in the developer would do no good nor any harm. So I believe we've gotten rid of all of the oxygen. So where we originally had a particle of silver forming the image, we now have joined it with a particle of chromium. Next we'll wash the film, and again this should be running water. 20 minutes would do well. Then we hang it up to dry. But today we'll hurry it up by using the absolute ethyl alcohol. So all of the yellow color has disappeared once the film has been through the developer process. All the oxygen has been removed. So now I'll put this back in the mount so that we can compare it with what we started with. We started with this too light radiograph, and we have chemically intensified it to this degree. That's been an improvement. However, we have not been successful in bringing it back to correspond to a so-called normal. Now, what we have done there can be illustrated on this chart. The original grains of silver are still present, but now associated with each one of them is a particle of chromium, which I've tried to indicate here in green. Now, the solutions that I have used are thrown out after we have completed the process. There's no sense in trying to save them for the next time. So this completes our discussion of the intensification process. Removal of processing solution stains from white fabrics. White cotton uniforms often become soiled from developer and fixer stains. Now, fresh, unused fixer solution will not stain clothing, but as films are fixed, silver salts accumulate in the solution, which may form spots on clothing that become apparent only after laundering. Now, I have a white cotton lab coat here with some spots on it, and these may be developer or they may be fixer spots. Now, if one splatters developer on his clothing, as soon as the wet spot dries, the developer stain would manifest itself. The ordinary laundry process employing soap and water would remove stains caused by developer. If used fixer were splashed onto this garment, as soon as it dried, you would see nothing. Then when the garment went through the laundry process and the ironing, then you would see the silver stains. These are silver stains which we're looking at here. Ordinary soap and water does not remove them. Now, the stain is caused by a complex silver ion which is not soluble in soap and water. So we're going to have to use a little chemical magic to remove these stains. Now, the instruments or the materials I use will be iodine and fresh, unused fixer. So we'll first take some iodine and apply it to this spot. There you see the light brown spot has disappeared. We treat the second spot in the same manner. Iodine is a strong oxidizing agent, and this treatment has broken down the complex silver ion into a common compound, sodium iodide, or silver iodide. Next, we take some of the fresh fixer and apply it to the darkened stain. And you see the dark stain disappears, and so does the fixer stain which we were first treating. Following this, the garment would be washed and dried and ironed. Now, there's another way in which I can treat the stain, and that is using a commercial product called Fix-Off. Now, this is a one-step process. So I have left one stain here for treatment. Now, I will apply the Fix-Off to the area, and hopefully it's going to remove it. Now, this doesn't function quite as rapidly as the other method, but we see that the stain is disappearing. Now, this happens to be a pocket, and it's a double thickness of material, so perhaps even a third application would help us to eliminate this spot. So now it's simply a matter of waiting, and the stain would disappear. The treatment involving the iodine and the fixer is rather harsh, rather drastic for synthetic materials. So if we're going to apply this to a nylon garment or Dacron or one of these synthetics, I would instead use the following. I would utilize a solution made up of sodium hypochlorite. This is 5% solution, and it's ordinary household bleach. 15 cc's of that, and then 15 cc's of household vinegar, which is the same as 5% acetic acid, and then added to 3.8 liters, and operating at 100 degrees Fahrenheit. I would soak the stained portion of this uniform made of synthetic material in this solution for 5 to 10 minutes, and then wring out the excess solution and place the garment then in fresh fixer. Again, 5 minutes or so would be entirely sufficient. Then following that, we would rinse the garment and dry and iron it, and we've saved somebody the cost of a new uniform. Now this iodine fixer treatment removes silver stains. It will not remove disclosing solution or any of these other troublesome dental compounds. Well, this concludes our demonstration of removal of processing solution stains from white fabrics.
You've been listening to a presentation from the University of Michigan School of Dentistry, which is dedicated to supporting open learning and open educational resources. This recording is licensed under the Creative Commons. It may be reused and redistributed for nonprofit use. Please attribute materials to the University of Michigan School of Dentistry and redistribute under this same license. For more information on how this and other University of Michigan School of Dentistry recordings may be used, visit www.dent.umich.edu/license.